graph the function y is equal to minus 1/4 raised to the x power minus 2. Then state the domain and range of this exponential function in interval notation. So to get us started here, let's observe that the graph of this exponential function, y is equal to minus 1/4 raised to the x power minus 2, is in fact a transformation of the graph y is equal to 1/4 raised to the x. So this is our parent function. Now to help us in sketching a graph of the desired exponential function, let's start by thinking about what the graph of our parent function looks like. So let's begin by creating a table of values. Now we know exponential functions have no domain restrictions, so we can let x be any real number our little hearts desire. So just plotting a few points, let's consider what the graph looks like at -1, at 0, and then we'll consider when x is positive 1. So when x is -1, we have that y is going to be equal to 1/4 raised to the -1. Now using properties of exponents, we can rewrite this 1/4 as 4 raised to the -1 raised to the -1. So we know that if we have an exponent raised to an exponent, this is like multiplying those exponents together. So -1 times -1 gives us +1, and 4 to the first is just 4. So here is the first ordered pair on the graph of our parent function. So adding a third column for x and y, we have the ordered pair -1, 4. Now when x is 0, we'll have 1/4 raised to the 0 power. And again, by properties of exponents, we know anything raised to the 0 is 1. So another solution point on the graph of our parent function is the ordered pair 0, 1. And last but certainly not least, we have 1/4 raised to the first power, which is equivalent to just 1/4. So our third solution point is the ordered pair 1, 1/4. Or we can convert that 1/4 to the decimal 0.25. So now that we have these 3 solution points on the graph of our parent function, let's go ahead and sketch a graph. So plotting our first ordered pair, -1, 4. Here is our solution point, and we'll label this -1, 4. The next point on the graph is the y-intercept at 0, 1. And last but not least, plotting the ordered pair 1, 1/4. We're somewhere down here. Now we can see the graph of this exponential function by connecting these 3 solution points with a smooth curve. So here is the graph of our parent function. This is y is equal to 1/4 raised to the x power. Now we can observe here, not only is this graph passing through these 3 solution points, but we can also see that our graph has a horizontal asymptote at the x-axis, or y equals 0. We can also see that the domain of the parent function is, of course, all real numbers, and that the range of the parent function is y must be strictly greater than 0, or y is an element of the interval from 0 to infinity. Now, from the graph of this parent function, we can attain the graph of the desired function, y is equal to -1/4 raised to the x power minus 2, using transformations and translations. Specifically, we are going to reflect the graph of the parent function across the x-axis, and then we're going to shift this result down 2 units. Let's now go ahead and think about each one of these individual transformations graphically. So considering the graph of the parent function as a dotted line, we can now take this parent function and reflect it across the x-axis. So observe that the ordered pairs on the parent function, negative 1, 4, 0, 1, and 1, 1/4, have been transformed to the ordered pairs negative 1, negative 4, 0, negative 1, and 1, negative 1/4, respectively. It's also important to note that even after this reflection across the x-axis, the graph still has a horizontal asymptote at the x-axis, or y equals 0. Now, using the graph for the reflection across the x-axis, we're now going to shift this graph down 2 units. So that means that the horizontal asymptote at y equals 0 has now been shifted down to y equals negative 2. This also means that the ordered pairs on the graph of the reflection across the x-axis, so negative 1, negative 4, 0, negative 1, and 1, negative 1/4, have also all been shifted down 2 units. Or in other words, they have been translated to the ordered pairs negative 1, negative 6, 0, negative 3, and 1, negative 9/4, or minus 2 1/4, respectively. Now, from this final graph of the desired function, minus 1 over 4 raised to the x power minus 2, we can see that we have a domain again of all real numbers. There's no restrictions on this exponential function. We can also see that for the range, y is going to be strictly less than negative 2. Or in interval notation, y is an element of the interval from negative infinity to negative 2. Making this our beautiful final answer.